Imagine holding a diamond that breathes, a flawless crystal that pulses with a life of its own, ticking like a grotesque eternal heart. It consumes no energy, it has no power source, yet it will beat forever, mocking the very concept of decay. This isn't science fiction. This is a time crystal, and it's a beautiful, terrifying middle finger to the known laws of the universe. To understand this beautiful monster, you first have to meet its arch nemesis, the second law of thermodynamics. Forget the boring textbook definition. This is the cosmic law of death, the universe's ultimate killjoy. It's the universal, inescapable truth that everything rots. Your hot coffee gets cold. Stars burn out. Mountains crumble into dust. Every single thing in existence is on an unstoppable one-way march toward a cold, chaotic nothingness. It is the law of endings. Now, think about a normal crystal, like a snowflake or a grain of salt. They are paragons of order in a universe that craves chaos. Their atoms are locked in a perfect, repeating grid. They've achieved stability by breaking symmetry in space. This is called breaking spatial translation symmetry. It just means if you scoot over a tiny bit, the pattern looks exactly the same. For decades, we assumed this was the only way for matter to find peace. Order in space. But what about order in time? In 2012, a Nobel laureate named Frank Wilczek decided to poke the cosmic bear with a very sharp stick. He looked at the universe's rulebook and asked a question so forbidden, so beautifully insane, it sent ripples through physics. He wondered, what if a system, in its absolute lowest energy state, its frozen, dead ground state, could spontaneously start moving in a repeating pattern? Not breaking symmetry in space, but breaking symmetry in time. A perpetual motion machine of the quantum world. The entire scientific establishment immediately screamed, no! There was even a rule against it, the no-go theorem. Physics was absolutely adamant. A system in its ground state cannot move. Period. By its very definition, the ground state is the point of zero motion, perfect stillness, absolute cold. To move requires energy, which would mean it's not in its ground state anymore. It was a paradox, a logical impossibility. A door slammed shut and locked from the inside. But of course, science is never about playing by the rules. It's about finding the grotesque, beautiful, reality-shattering loopholes. And physicists found a cheat code etched into the very fabric of quantum mechanics. It's called a Floquet system, a fancy name for something deliciously simple. You never let the system rest. You don't give it a chance to bleed out its energy and settle into that boring, motionless ground state. Instead, you get a laser and you start poking it again and again and again with a perfect rhythmic pulse. You drive it, you agitate it, you force it into a state of perpetual twitching existence. It's a form of cosmic torment that prevents the universe's natural decay. By constantly pumping in energy, you create a stable, repeating pattern that shouldn't exist. You're not just stopping the clock, you're forcing it to tick to your own unnatural beat, cheating the second law of thermodynamics itself. So how does this cosmic bullying create a time crystal? Imagine a line of twitching, sentient dominoes. Your laser is a giant spectral finger that flicks over every 10th domino, once every second. A normal system would just have that 10th domino fall. But in this quantum madhouse, something else happens. The entire chain of dominoes reacts. They all fall over together. And then, a moment later, they all lurch back upright, resetting themselves. The finger is poking every 1 second, but the dominoes are falling and rising every 2 seconds. They've developed their own internal rhythm, their own ghostly heartbeat. This is the key. The system isn't just mimicking the laser pulse you're hitting it with. It's adopted a new, longer, and completely independent period of motion. It remembers the poke, but responds on its own schedule. It's a clock forged from chaos, ticking at a frequency that breaks the symmetry of the timeline you're imposing on it. And this isn't just some fever dream scribbled on a blackboard. Scientists at the University of Maryland and Harvard built this monster. They descended into labs colder than the void between galaxies, creating a vacuum chamber of absolute stillness. Inside, they trapped a tiny chain of ytterbium ions, a glowing string of atoms held perfectly in place by invisible electromagnetic fields. Then, with the precision of a mad surgeon, they zapped these ions with a sequence of laser pulses, one pulse to mess with their quantum spin, another to lock in the interaction. Poke and poke again. And they watched as the chain of atoms began to oscillate, to flip their spins back and forth, not in time with the laser, but at exactly half the frequency. They had built it, a real ticking time crystal. This wasn't just a weird new gadget. This was the discovery of a completely new phase of matter. We all learn the basics. You have your solids, your liquids, your gases, and if you're fancy, you know about plasma. These are phases of matter in equilibrium, states where everything has settled down into a stable arrangement. But a time crystal is something else entirely. It is the first out-of-equilibrium phase of matter. Its entire existence is defined by its constant, structured motion. It's a solid that moves forever, a liquid that never stills, a gas that never dissipates. It's matter that has time baked directly into its very structure. So forget about perpetual motion machines. That's a sideshow attraction. The real gut-twisting horror here is what this does to our concept of time. You see, physics is built on a sacred, supposedly unbreakable rule called time translation symmetry. It's a fancy way of saying the laws of the universe are the same on Tuesday as they are on a billion-year-old Thursday. Drop an apple, it falls. That law worked for Newton, it works for you, and it should work for some tentacled alien in the Andromeda Galaxy a million years from now. It's the ultimate bedrock of reality. It's comforting, it's stable, and the time crystal takes a sledgehammer to it. By oscillating in its ground state, a time crystal proves that at the quantum level, this symmetry can be spontaneously shattered. It creates a region of reality where the rules have a stutter, a tick, a preferred rhythm. It means time isn't a smooth, flowing river. It's a river that can have whirlpools, eddies, and grotesque pulsing currents that exist for no reason at all. And what can you do with a rip in the fabric of time? You can build a computer out of it. Quantum computers rely on things called qubits, which are notoriously fragile little beasts. A stray cosmic ray, a bit of heat, even looking at them funny can make them collapse into uselessness. They are like thoughts made of smoke. But a time crystal qubit? Oh, that's a different monster entirely. Its rhythm is protected by the very laws of space-time it's breaking. It's a bit of information that isn't stored in space, but in a recurring pattern in time. Imagine a hard drive that saves your data not on a magnetic disk, but in an eternal, unerasable echo. That's the grotesque promise here. This discovery rips open a Pandora's box of terrifying questions. We just broke a fundamental symmetry of time. What other cosmic laws, once thought to be absolute, are actually just. Suggestions? Are there other, more bizarre symmetries we haven't even conceived of, just waiting for us to find the right quantum crowbar to pry them loose? Could there be natural time crystals out there, humming away in the universe? Imagine a neutron star, its core crushed into a state of matter so dense it begins to pulse, not just with energy, but with a rhythm that distorts the flow of time around it. A cosmic metronome setting a beat for reality itself. This leads to the most unsettling conclusion of all. For over a century, we've been haunted by the idea of the heat death of the universe. The slow, inevitable slide into maximum entropy, where everything becomes a thin, cold, boring soup of nothing. A final, silent equilibrium. But time crystals laugh in the face of entropy. They demonstrate that even at the lowest possible energy state, the universe can host eternal, complex, ordered motion. Our universe isn't destined for a quiet, uniform death. It has the capacity for a grotesque, persistent, and rhythmic life embedded in its very structure. We thought we were living inside a giant, magnificent clock that was slowly winding down. The truth is so much stranger. We are living inside a bizarre, twitching biological specimen, and we just found its pulse. But you thought we were done? Oh, you sweet, naive fool. The laboratory was just the nursery. Now we unleash this temporal monstrosity into the cosmos, and we find that the universe might have been ticking to this bizarre rhythm all along. This isn't just a new material, it's a crack in the mirror of reality, and something unsettling is looking back. Some physicists, the ones who stare into the void a little too long, whisper of cosmological time crystals. They ask, what if the Big Bang wasn't a one-time explosion, but the first tick of a universe-sized clock? An eternal oscillation, a cosmic heartbeat where the entire fabric of spacetime is the crystal, pulsing in a way we can't perceive because we're inside it. Think about black holes for a second. They are the universe's ultimate garbage disposals, gobbling up stars and planets and, most disturbingly, all the information they contain. For decades, physics has been screaming that this is impossible. Information can't be destroyed. It's a paradox that has kept scientists awake at night, sweating into their pillows. But what if the information isn't gone? What if it's just changed? What if the singularity at the heart of a black hole is the most perfect time crystal imaginable, storing the data of a consumed star not in space, but in an infinitely repeating temporal pattern? A ghost of a sun, trapped in a timeless, ticking prison. Let's get personal. Let's get squishy. Your brain is an electrical storm of organized chaos, a symphony of firing neurons. But what if that pattern, that delicate, impossibly complex rhythm that creates you, is more than just chemistry? What if consciousness itself is a form of biological time crystal? Imagine your very identity, your memories, your fears, all encoded in a quantum oscillation that repeats and evolves without consuming energy. You aren't a thing, you're a rhythm, a persistent temporal echo. And if that rhythm is disrupted, poof, the song ends. You never were. A terrifyingly fragile state of matter. This is what happens when a fundamental symmetry of the universe is shattered. It makes us ask the most dangerous question a scientist can ask. What's next? If time isn't smooth and continuous, what about causality? Could we build something that jiggles cause and effect out of order? We've picked the lock on time. Now we're staring at the other doors. The speed of light? Is that a hard limit or just a cosmic suggestion? The conservation of energy? We already bent that rule to make these things. We are no longer just observing the universe. We are actively looking for the back doors, the cheat codes left behind by whatever mad programmer wrote this reality. The practical applications are even more grotesque. Forget quantum computers. Imagine a hard drive that stores data in the fourth dimension, its memory invulnerable to physical decay because it doesn't exist in a single moment. Or a weapon that doesn't destroy things, but instead rewrites their temporal signature, making it so they were never built in the first place. Time crystals prove that the universe isn't a silent, empty stage where things happen. It is an active, churning, and deeply weird machine. It has a pulse. It has a structure. It is alive in a way we never thought possible, and its heartbeat is a constant, terrifying reminder that the deepest laws of reality are not just breakable, they're begging to be broken.